In this video, we will be introducing the mole unit. This is a conceptual video to help you understand what a mole is so that in subsequent videos we can learn to convert amounts of substances among moles, particles, and mass. So we just learned how to calculate the formula mass of one molecule or one formula unit. And so we can figure out that this is water, H2O, and its formula mass is 18.02 atomic mass units. And so one molecule has a mass of 18.02 atomic mass units. But our laboratory scales are not sensitive enough to weigh individual atoms. We will be weighing things in grams or milligrams, most often grams. And so we need to be able to know, just by weighing, how many molecules things are. And so we need a way of pretty much calculating from 40 grams of something, how many molecules that corresponds to. And so if this was 40 grams of water, how many molecules is that? We can't sit there and count them. And so if we make an analogy to what we're about to do, when you shop for vegetables or produce, then a lot of vegetables are sold by the pound rather than individual counts. And so if you fill a bag with green beans, the cashier doesn't have to count how many green beans did you purchase, they just have to weigh them. And so a lot of fruits and vegetables are sold by weight rather than each. Although you do have to watch it though, because Target sells bananas by the each, and so just look closely at the tags to know whether you're buying things by the pound or by each. The advantage to selling things by the pound is that it's a lot faster than counting. So a lot of food is sold by weight rather than counts of individual items. And so our goal is to be able to calculate from grams how many moles that is, and from moles how many counts that is. But since we're dealing with so many counts, a lot of times we just stop at moles because it's a lot easier to deal with a number like 1 than 6.022 times 10 to the 23rd. And so it's a lot easier to deal with a number like 1 than some big crazy number in scientific notation. So when we introduce this mole unit, it's a unit of quantity. And you're probably familiar with some units of quantity, such as a dozen. 1 dozen is 12. And so if I buy a dozen eggs, that means I bought 12 eggs. If I buy a dozen donuts, then I bought 12 donuts. And so 1 dozen equals 12 things. It doesn't matter what the things are, it just matters that there's 12 of them. If you buy a ream of paper, then that's 500 sheets. And you can buy cases of soda that are either 12 packs or 24 packs, but like they're units of counts. If you have a dozen, it's called a gross. And so 144 things is a gross, which is a dozen. And then if we have 6.022 times 10 to the 23rd power of things, then we call that a mole. So it's like a chemist's dozen. A mole is a chemist's dozen. So the mole unit, which is abbreviated MOL, is an SI unit for the amount of substance. It defines 1 mole as containing exactly 6.022140076 times 10 to the 23rd power elementary entities. Now this has a lot of sig figs to it. A lot of times we will use a more rounded value of just 6.022. So that's the one I expect you to know. If you need the more precise measurement for any reason, then a lot of scientific calculators actually have this programmed in as a constant, and so you can look it up and reference the more precise value. I believe the more precise value, well, it's slightly more precise on the yellow reference sheet, but not terribly more precise. The mole was officially redefined in 2018. Previously, it did reference carbon-12 as the reference point, and in 2018, when SI units started being revised to no longer depend on physical objects, then it just got defined to this fixed value here. And so this is written in scientific notation. This number is taken out of scientific notation. And so you can see that this is a very big number. And so it's a very big count of objects. And so all of these containers here contain just 1 mole of that substance. You can see that each substance has a different volume to it. All of them would have different masses as well, but each thing has the same number of particles in it. And so each of these contains 6.022 times 10 to the 23rd power, either molecules or formula units, or individual atoms for the pure substances. And so each of these contains just 1 mole of that substance. Different masses, different volumes, but same count of things, same count of particles. So why did they pick 6.022 times 10 to the 23rd power? Why didn't they pick something like 1 times 10 to the 23rd power? Well, they picked this number because it made math easy to convert between the units of grams and atomic mass units. There's 1 gram, it's equal to 6.022 times 10 to the 23rd power atomic mass units. And so this number just made math nice and pretty. And then we don't have to deal with some really ugly counts of things later on. So it just makes math easy. It's known as Avogadro's number based on this guy. This is Avogadro, and he did a lot of work in early chemistry trying to relate number of particles to things like volume for gases, and so he got this named after him, this number named after him. You might notice that his name of Avogadro sounds a lot like avocado, and then you're probably thinking about guacamole or guacamole. Mole. And so, what do you get? You get guacamole. And so this is an actual product sold at Trader Joe's, and so you got to go get some avocados number guacamole so that you can enjoy it and enjoy the pun. Okay, and you can see that Avogadro's picture is right on the front. And now you can actually get it. And you should read the back of the box too. I got a box, it's up in my office. Anyway, so they picked this number because it made math easy. It makes math so easy that we don't ever have to use this 1 gram is that many atomic mass units. We will be reading things off of the periodic table in either atomic mass units or grams per mole. So that atomic mass of magnesium, for instance, magnesium is either 24.31 atomic mass units, or it's 24.31 grams per mole. And so this makes our math very nice. So we will be using molar mass quite a lot in this course. That's our go-to conversion. There is a side note that since we defined carbon-12 earlier as having a mass of exactly 12 atomic mass units, 1 mole of carbon-12 has a mass of exactly 12 grams. So when we calculated formula mass, we added up the masses of all the different carbon atoms, all the different hydrogen atoms, and the oxygen atoms, and we could get a formula mass, or also known as molecular mass if it's for a molecular compound. then you can get this in atomic mass units. Molar mass is on the mole scale. And so 1 mole of sucrose looks like this rather than one individual molecule. And it has this mass, and so we would read its molar mass as this many grams per mole. And so the units of molar mass are grams per mole, but it's calculated in the exact same way as formula mass. We are just going to read off the masses of the individual elements from the periodic table, add them together, and then slap some units on it of grams per mole. So here's a conceptual checkpoint for you. It reads, which of the following contains the largest number of atoms? Go ahead and pause the video and try to determine which contains the largest number of atoms. Did you pick answer A? If so, you are correct. But let's talk about why it's answer A. So it does talk about number of atoms. Br2 would have 2 atoms per molecule. This one has 3 atoms per molecule. And so 2 moles of Br2 would have 4 moles of atoms. This one has 3 moles of atoms. This one is just an individual atomic element, and so 3 moles of this substance would just have 3 moles of atoms. And so 2 moles of Br2 contains the highest number of moles of atoms. In our next video, we will be learning about converting between mass and moles.